So, I did say about having a message, coding it, encrypting it, and then it comes out as an encrypted message, and then you want to be able to go from that message back to what, or the encrypted message, you want to decode it or decrypt it and go back to the original message, right? So in the book it talks about that mod 26 thing. Do you understand what that means to start with? Yeah? Could someone just explain that quickly, Odin? I'm just waiting for you to explain in like proper sentences and in one go. What does the mod mean? You don't remember, no? Jack?
It basically means if it's mod 26 that every time you reach 26 you go back to 1.
Okay.
So you can keep
so that number is what goes with the letter. Is that? Yeah? So we're attributing A would be number 1, B would be number 2, and so on. When you get all the way up to Z, you'd be at 26. So then we would say 27 would be A. Okay? So what would the mod, when it says mod 26, what does that mean? But what if I said mod 27 or mod 38? What would that mean? Liam?
It would mean you go full time around.
It just changes the number of numbers in the cycle.
Okay, so if I'm doing mod 29, for instance, what would that do here? Yeah? Do people understand the old mod thing? No? Okay. Then? Only just had lunch. If you're desperate, you need to go. But you need to think about it next time, please. Right, anyway, we'll come back to this to talk about, but basically what we're going to use is the fact that some of these letters have been replaced by numbers. Okay? And what we can still do is, if we start with our initial message, let's pick an easy word like cat. What would cat be as a set of numbers? Desmond?
3, 1. Let's see.
Oh, you put your hand up.
F, G, H, I, J, K, L, M, N, O, P, Q, R, S, 20.
20, do we think? Yeah?
Yeah.
So 3, 1, and 20. So my first level would be to turn my letters into numbers. Are you happy with that?
Yeah.
All right. So then the way to encrypt this message would be to use a mathematical function. And the mathematical function that I'm going to be, it could be anything. All right? And I'm going to use one that says 2 lots of C. C, okay. I'm going to go plus 5. So these are my C's. All right? So this would be my message, and this would be my code then. So how do I get what my cat would be? So I would do the first letter, so C, then A, then T, and I would say, well, it's 2 lots of 3 plus 5 would give me, all right, 2 lots of 1 plus 5 would give me, and 2 lots of 20 plus 5 would give me. Okay. Now that number we can then convert into our letters again. So what would my 11th letter be? K? I'm trusting you.
Oh, yeah.
7 would be an H.
Okay.
And 45th. Okay, so we go take 26 away until we keep, until we get to a number lower than 26, or we go the other way and just say every 26th letter is a G is 7, is it? Or 7 is a G? Okay.
Yeah.
A, B, C, D, E, F, G. Yeah. Okay? I could say, like, every 26th number is, sorry, every 26th letter is a Z, yeah? I want to say Z, that's why I'm pausing. Z. So 26th letter is a Z, the 52nd letter is a Z, so I can kind of work back in that way, or do what the guys are saying and just subtract 26. So whichever way, I've just got to work out. Imagine the A to Z keeps repeating itself. So obviously after 26, it repeats and starts again A to Z and so on. All right, so what would the 45th letter be? However you want to do it. It's an S, or is it?
Yeah, it's 19, one behind T.
Yeah, I had it on the
S?
Yeah, I was just counting on
Well, T is 20. Yeah, T is 20.
See, I just did
19 is that?
Yeah, it's us.
We think it's S? Okay. Now, we do have a... What I was talking about then was what we call the inverse functions. Okay? Now you might find an issue with this, because obviously everything we do, we're talking about what the limitations are. So with an inverse function, what I actually want to do is to be able to go back from these numbers back to these numbers. Okay? So in my function, 3 gave me a 11, and 1 gave me a 7, and 20 gave me a 45. So what I want to do is be able to go backwards. So I want to do the opposite of what I did. And the other word of saying opposite is inverse. So like you were all mentioning before about inverse operations, they are the operations that undo what happened before, yeah? So the inverse of multiplying is to divide. The inverse of subtraction is to add. And Cameron made a point, if I have multiple operations happening, I must also do the opposite of the order in which it happens, so the opposite of both. Odin. Okay, so what we would do, I'll make it very clear. So what we do is we take our C number and we think about what did I have to do to that to get the coded. And the first thing I had to do was multiply it by 2. So what I'm writing here, this is kind of called a function machine. I'm sure you've seen it before. So first of all, I multiply by 2. Now you'll get to a stage where you don't need to write these out, this flow diagram. Okay? I multiplied by 2, and that gave me some answer. Gives me an intermediate step. I then take that answer and I do what with it? Add 5. And that gives me my coded answer. Okay? All right? Now we would give that some letter to represent it's the coded answer. So what do you want to say? So we've got C and then it goes to D. Okay. Imaginative. Like it. So to do my inverse function now, I've got to go back the way I came. I've got to be able to do it in that order. So I start with my D number. I have to do the opposite of what happened and in the opposite order. So I have to subtract the 5, doing circles for inverses. Okay? That should tell me what that question mark was. It should be exactly the same. And then I take that number and I should be able to divide that by 2 and I should get back to whatever my C was. All right? Now I said yesterday about being able to verify. So obviously in our MYP criterion, one of the big words is to be able to verify that you're correct or incorrect. So we had to verify. Does anyone remember how to? Ava? Substitute. So what are you going to substitute for me? So we are checking that if I put what in? 3. So when 3 goes through, I know that the intermediate number is 6, and then what comes out is 11. That was one we did up here. Okay, that one there. So what should be able to happen then, if I'm correct, right, is I should be able to put 11 in. 11 minus 5 is 6. 6 divided by 2 is 3. And I can make the statement that those two are the same. Okay, so I'm happy I have verified that I am correct. So that is our action of verification. Now, where we can go next though is we still haven't really written our inverse function. Okay. So my code, oh sorry, I should have an O in there, you know that. The code is D equals 2 lots of C plus 5. The inverse function is C equals 2 lots of D minus 5. You're wrong, aren't you? Yes. Why? Well, first,
Half of D.
so you have to do things in the correct order, remember. So what do? I start with D and then I minus 5 first. Then that whole answer is divided by 2. Okay? Now that would be my inverse function. Now, let me wait. I said to you yesterday I'd talk about the swapping the things around. So in the book, it talks just X's and Y's. All right, X's and Y's. And the X's and Y's don't really have any link to anything. So what they will say in the book is they will say the inverse function, you then swap the letters around. All right, so let me just explain. If I'm not talking about coding, I could just say to you, I have got y equals 2x plus 5. The inverse function would be y equals x minus 5 all divided by 2. Okay? Now that's true, that's fine. In fact, each one is the inverse of the other one. I've swapped the letters because that's what normally happens. But remember I said yesterday, we do it, so don't let me make you think you don't do that. But it doesn't really make any sense to swap the letters when you're in an applied sense. Why not? Why shouldn't I swap my C and my D? That Yeah. Exactly. D is the coded one, isn't it? C is the normal one. So if I swap my C and my D afterwards, I then do it completely the wrong way around, don't I? So I shouldn't swap the C and the D. And I said I'd give you another situation, which was to do with a proper financial situation. Has anyone ever spoke to their parents about how much it costs to, you know, get a plumber out to the house or something like that? It's expensive. So the way it works is the cost to you, all right, is equal to, let's say it's $100 just to get them to come to your house, plus, let's keep it cheap, $80 for every hour they work. All right? So this function takes the number of hours they work and works out the cost to you. So working for 5 hours costs you how much? 80 lots of 5 is 400 plus the 100, $500. Okay. What should the inverse function do? It should. Karen? Yeah, so if I know my cost, I can work out how many hours that guy should have worked. And I would do that as a customer because I get a bill, and that bill is, yeah, depends, doesn't it? So let's say the bill is $900. So I need to work out, well, how long should he have worked for that? So I want to use the inverse function. So what is the inverse function? So remember, what we do is we take our hours and we do what? We times 80, then we plus 100, and we get the answer 900. So then we do the inverse function, which is 900 minus 100, which is 800, divide by 80, which is 10. So it's 10 hours. Now, that's easy enough, but let's do it in terms of algebra. So what's my function? This is this function. What's the inverse function? H equals No, I want the actual function, not with numbers. I want it that can work for any situation. So what do I do? So this was H, this was C. So what did I do? First of all, I did C, then minus 100. So I do C, subtract 100, divide by 80. So that's this is my function. This is my inverse function. Make sense? All right. Now tell me what's wrong if I swap the C and the H at the end. Odin. Yeah, it would change it completely. The whole meaning would change completely. So this is an important thing. When you are just doing inverse functions that have no real specific meaning, you'll be told to swap the x and the y around. Because what we will do eventually is graph these as well, put them on a graph. And that's why you have the x and the y's and you swap them. However, don't think that you always just swap them, because if they're in a particular situation like this, it doesn't make any sense. So now you've got two things. Do you understand? First of all, do you understand how to write an inverse function? So summarise for me what you need to do. Liam. So the exact opposite. And you need to consider two things, which are the opposite order and the opposite operations. So you must do the operations, the opposite operations, and in the opposite order. Now that means you must be able to read it the right way round. So you need to really think what you're doing. Okay? So, you are still looking then at page, what are we doing? Page 172, you've got practice 7. If you are still working through that, absolutely fine. I think you probably all are, yeah?
Yeah.
Cool. Let me know if you need any help. Try and get that finished, and we'll want to move on to inequalities tomorrow. Just to check. So, one function that's been giving people issues is we've got y equals negative 6x plus 12, and the inverse function ends up being y equals x minus 12 divided by negative 6, which is not the answer in the back of the book. Okay? Right? The answer in the back of the book is y equals negative x over 6 plus 2. Okay? Now, is everyone happy why it's not simpler actually, it's just in a different form. It comes from a way of doing it slightly different. We're going to talk about tomorrow. Is everyone happy that those two are the same thing?
Yes.
Why then? And
Because when you divide 12, a negative 12 by negative 6, when you divide the two negatives, it's positive. So
yeah.
12 divided by
So
6
first of all,
is
let me just point out that we have to do this and this divided by negative 6. So we have x divided by negative 6 and negative 12 divided by negative 6.
negative 0.
So this stays as it is, and this becomes positive 2. Okay? That's why. So a lot of the answers in the back of the book are different to what you're ending up with because of the way I've shown you what to do. Tomorrow we're going to talk about it a little bit differently, but you need to be aware that sometimes you're not wrong, you just have it in an equivalent form. Okay?